focus your which were used in algebra to describe linear change. Are there geometric patterns within slope triangles themselves that you can use to answer other questions? In this lesson, you'll look closely at slope triangles on different lines to explore their patterns.
Thank you. Okay. So you can look at right here in the diagram. That's the Leaning Tower of Pisa, which is probably a good real life example to look at because it does lean. It's not a straight up tower, right? So let's look at the next one. Colette, do you mind reading where it says for centuries?
Marveled at the Leaning Tower of Pisa due to its slant and beauty. Ever since the construction of the tower started in the 1100s, the tower has slowly tilted south and has increasingly been at risk of falling over. It is feared that the angle of the slant ever falls below 83 degrees, the tower will collapse.
Yeah, cool. Yeah, and so I'll read the next part. Engineers closely monitor the angle at which a tower leans. With careful measuring, they know that the point labeled A, okay, which is the top of the tower, close to it, the diagram on the right is now 50 meters off the ground. Okay, fine, fair enough. Also determined that when a weight is dropped from point A, it lands 5 meters from the base. Okay, fair enough too, right? So they have that as well. As shown in the diagram. With the measurements provided, what can you determine? Okay. But we haven't learned any trigonometry yet, so I'm not going to get into that today. That's kind of crazy. But what we could do is we could probably figure out that side. Let me label this as B and C. So what can you determine? I could provide AC. AC is the hypotenuse. And my left click button on my mouse sucks right now. Sorry about that. But we could figure out AC. I mean, I'm not sure that's going to help us, but we could. How would you do that? How would you find that? Maggie, what?
Could you do like pi fact?
Yes. And so set up 5 squared. Mhm. Perfect. Good.
25 plus,
Yeah, I'm just going to use the trackpad here. Yeah, 5 squared plus 50 squared. Oh my goodness, today's going to be a struggle. Equals, I'll call it C. Equals C squared.
Does it matter like the order you do it in? Like,
But you could do 50 squared first and 5 squared second.
you know, like, because
But you can't put 50 or 5 on the other side, though.
like the legs equal the hypotenuse.
Exactly. And 5 and 50 are my legs.
Oh.
Because look where the right angle is, right? The legs are always where the right angles are. Yeah, I know it's a little confusing because 50 is off to the right. Like you're probably thinking it looks like this.
Yeah.
But you have to kind of like look at it from a different perspective. Yeah. So as Maggie says, 25 and 2500. So that is kind of a weird number. Actually, it might be so weird. Okay, now my mouse is working. That's funny. What's happening there? 25 square rooted. So it's 50.25. Meters. So that's the side of the building that's kind of leaning, right? Also, we can figure out the slope of AC. That's what we really want to be present to, by the way. So the slope. So remember how to find slope? What's the formula for slope? You guys remember? That's the equation line, but how about M? How do you find M though? That's right. So let's look at right. Yes, good. Rise or run. Yes. Rise over run. So if I think about it, if I start over here, right? How far do I rise and how far do I run? Or if I go over here, actually that's a little confusing because it's tilting this way. So how far do I rise and how far do I run? So how far is the rise here? How far is the run? There we go. That's it. That's all it ever is. The rise is 50. So if you think, let me draw it one more time. It's a little confusing. Let's say AC looks like that. So how far do you rise? How far do you run? So how far do I rise? And how far do I run? And so if you look at the diagram, you rise up 50 because it's 50 meters off the ground. This little part here where point A is, and it runs 5 meters. So it's 50 over 5, which is 10. And if that slope gets smaller, then we have a problem, right? Because then it's going to probably fall over. So what can you say about the angle at which it leans, not learns? That's a typo, which it leans. Can you give a rough estimate? Well, it's definitely not 90 degrees. Can you turn its exact value? So you could say it's what can you say about the angle at which it leans? Close to 90, but not exactly. But not exactly. Can you give a rough estimate? Sure, what are you saying, Colette? Like, yeah, probably mid-80s. Almost, yeah. Can you turn its exact value? Yes, but not now. Have you guys, I don't know what you guys did in middle school. Do you guys do like sine, cosine, tangent? Does that ring a bell? No, you guys don't learn it. That's okay. We'll yes, but not now. Later, you'll learn trigonometry. So I'm going to teach you guys that in the spring, most likely. Trigonometry stands for right triangle geometry. You will learn that, and you will, but not now. Eventually, you will. Okay, so it's just more exploring, just looking at slope. Just there's really nothing more than that. It's not like a homework. It's not like a test problem like that. But we will start getting to. Oh, thanks. Appreciate it. We'll start getting more details, like more test style questions or homework questions in just a moment. So patterns and slope triangles. Lucas, can you read that part where it says 4-2?
In order to find an angle such as the angle at which the leaning tower of Pisa leans, we need to investigate the relationship between the angles and the sides of the right triangle. We will start by studying slope triangles.
Perfect. Thank you. So for the next several lessons, angle measure will be rounded to the nearest degree. Okay, so that's what we'll do. So whole numbers. If you want to do that, whole numbers. Draw 3 new slope triangles different size on the line. Label each triangle with its horizontal and vertical lengths and its angle measures. Okay. So you could actually, if you wanted to, I didn't have to go 5 right and 1 up. Could I have done this? Okay, look what I drew in red. How far am I going right? How far is that? How far up? Not quite. 2. Yep. So if you think about it, 1 to 5, does that equal 2 to 10?
Yeah.
Yep. Okay. Let's draw another one. Let's go blue. $11, $12, $13, $14, $15. Okay, let's look at blue. How far am I going right at the blue? How far up? Perfect. Is that the same ratio as the other two? Yep. And then lastly, we'll go green. Go forest green. Sorry for a little colorblind. 16, 17, 18. Okay, how far did I go with the green? And how far up? So 4 over 20. So what we're seeing here is that the ratio is always consistent. The slope ratio is constant. It does not change. Because you're dealing with the same, and the reason why it's determined by the angle. I'm sure many of you guys go to Tahoe during the winter, and when you drive up, like off Highway 50 if you're going south, or Highway 80 if you're going to, towards the north, I know Incline Village is very popular around here. You guys see sometimes it says a slope, right? Sometimes they see like trucks should like, be mindful of their brakes or switch a lower gear because, so they do give the angle if you notice that. And so, oh, bless you. So it's determined by the angle. If you have a steeper angle, what do you think is gonna happen to the slope? If the angle steeper goes up, it's gonna be higher. Yeah, exactly. If it's a lower angle, not as steep. Or what if you're like, like going for a hike, like, I mean, or going for a jog, Valparaiso is flat, right? Has anyone like tried to go all the way up to like if you go Valparaiso, like past Alameda and go past the fire station, okay, that's a little tougher, right? Because it's very steep, right? You're gonna start, huffing and puffing. So, so yeah, that's what we see with the angles, right? Obviously, it's bigger angles, more steep. So, right to slope ratio for each triangle you made as a fraction. I already did that. I already did part B. That's done for us. In fact, actually, I could just move it. Move it down here. Sorry, took care of that. Explain why all of them are similar. I already did that also. Determined by the angle. So we know that now. So sorry, I'm a little out of order, but determined by the angle. So that's why it's constant. Hopefully this is intuitive. Like again, think about driving to Tahoe or walking on Valparaiso or going up the hill towards Highway 280. All right. Okay, cool. Let's move on to the next part. Okay, Sabine, can you read 4.3 for us, please? The beginning part. Okay, so she asked, what if I drew a slope triangle where the change in y, so this is the rise is 6. Okay, fine. So delta y over delta x. By the way, in math, the triangle means delta is the Greek alphabet. Why these Greek alphabets, I don't know. But it is what it is. So that's 6. But I don't know the delta x, right? But what was the ratio? The ratio every time was what? What was my ratio above? 1/5, right? Or 2/10 or 3/15. But consistent was always 1/5. Right? It's always 1/5. So what would that be for delta x? Well, just do 6 over delta x equals 1/5. Now you guys see why I'm so hell-bent on proportions. This is a very important skill to have. What do you think delta x is going to equal to make this true? Yeah, 30. Because if you cross multiply, which you're allowed to do if you have a fraction on each side, and there's an equal, you're totally allowed to do that. Yeah, delta x equals 30. And yeah, delta x equals 30. I'm going to move the screen just a moment. Let me go and clear this for a moment. I'll bring it back. But if you were to find 6, see, that was, gosh, let me extend this here. That was 4. 1, 2, 3, 4. That was 5. That'd be 6. So if that's 6, if you think about it, if you mark it off, 5, 10, 15, 20, 25, 30. You guys see how that works? And by the way, this ties very closely to some of triangles. Ties very closely to it because you're looking at ratios again. So hopefully you guys can see visually why that 30 has to make sense as well. All right, so hopefully we're cool with that. All right, so now the next one. Go and try part B on your own, or you can talk to your elbow partner. And then Try to answer part C. And I'll freeze the screen. We'll share in about 2 minutes. Bless you. Okay. Please. Yes. That was for pre-calc. Thank you though. That's next period. Thanks so much. Yeah. No one else. Thank you. Appreciate it. All right, here we go. Okay, so we got 8. Does 8 make sense? Yep. You want to maintain that ratio? 8 and 40 is 1/5, right? You can cross multiply. 5 times alpha y equals 40 times 1. So alpha y should be 8. And see, it's kind of a weird question. What if I drew a different line? It depends. It depends. As long as the line you drew, the angle between the line and the run is a horizontal segment, right? As long as that stays the same, then yeah, it won't matter. Like, what if I drew a line that's parallel? The line at the above. It's fine. It's okay. But if you drew a line that's more steep or less steep, then of course it changes. But you have to maintain that angle. Was there a question paper?
Yeah, cause I said like no, because
That's fine too.
the line might not have like the same.
Yeah, that's me about CPM. You could give a different answer. CPM actually encourages different answers. If you said no, that's fine, as long as you said the slope change, the angle changed. That's fine. That's fine. Yeah.
It's like,
It is. It's there's not a 100% correct answer. You can give multiple answers. It's what we care about is your reason. That's all I care about. You could say, I don't know, like, well, World Series is over now. Now we're on the football. Will the Warriors win the championship? Sure, because Steph Curry is great. Or no, because Spurs are better. I don't know. Like, I'm just kind of crazy reasons, but but you give your reason. That's all that matters. Give a reason. Yeah, sure. Yeah, of course. But that's a valid reason. If you said yes, or in Faith's case, he said no because the angle changed. It's up to you. All right, cool. So we're doing the law of exploring. Okay, now we're gonna move on to whoa, that's kind of weird. Your teacher lab, I don't know what this Desmos is. We'll worry about that later. I gotta talk to Davis about it. Okay, now we're gonna start introducing trigonometry. So actually, I kind of lied. We are gonna talk about trig. Maybe not all the trig stuff, but we're gonna talk a little about trig right now. So we're gonna talk about something called a tangent function. Let me tell you what's happening here. So the tangent is a ratio. So now we're beginning trig. So I said not now, like not at that current moment, but now we're going to talk about a little bit. So the tangent of an angle is a ratio of the opposite side and its adjacent side. So angle B is right here. This side's opposite. This side's adjacent. Okay. So it would be AC over BC. You guys see that? Yeah, Congo. Great question. Great question. Okay. BA has a special designation. What do we call BA in the right triangle? What name does BA get? Hypotenuse. So it doesn't count. So tangent only uses legs. Let me make that clear. Tangent only uses legs. Only legs of the right triangle. Not the hypotenuse. Okay, not the hypotenuse. So if I do it the other way around, tangent A. So if I look at A now, right? What's opposite angle angle A? Yes, now it's just reversed. So it doesn't matter what angle you're looking at, BC or AC. And you're only going to use is an angle. That's a typo there. Has to be acute. Which means less than 90 degrees. And the output's a ratio opposite over adjacent. So this ties closely to slope. Connor, go ahead. Yes, we are. Yes. In the next problem, we will. So in this course, we'll discuss only tangent for acute angles within a right triangle. The hypotenuse of a triangle will never be the opposite or the adjacent side in a tangent. Hold on. Yeah, hypotenuse doesn't count, right? Only legs. I do think we talk about sine and cosine, though. I have to double check. I know we talk about algebra 2. It says we only discuss tangent. I don't think that's correct, but I could be wrong. So let's move on to the next problem. Here we got this. Simi, did I have you read already? Yeah, I did. Yeah. Cam, can you read the next one? Problem solving tangent.
The tower is 45 feet in height. How far is the partner from the base of the tower to the nearest and middle?
Okay, depression. So there's going to be two terms we're going to use, depression and elevation. Okay, if your spirits are elevated, what does that mean? If you look at, so you're going to look up. You're looking up, right? That's up. If you're depressed, like you're sad, your head's probably down, right? Probably got your head down. So that's what's happening here. There's probably a guard here, and he's looking down. So his guard's right here, right? And he's got to look down. How far does he have to look down? 40 degrees. So angle depression is always your line of sight. That's where you tilt down, right? Now, this dashed line and the ground here. What do you think is true about both these lines? Yes, they're parallel. Yes, they're totally parallel. 100% they are. So this is parallel to this. So if this is 40 between the guard and the line of sight, or sorry, not the line of sight, the actually the new line of sight to the other guard down below, then what's this angle here? That's 40 also. So you have to use alternate interior angles, just so you know. Are congruent. Cool, go ahead, yeah.
Like angle, like the watchtower to the ground, if it's missing those, that's 50. and
Yes, yes, correct, right. Yeah, this would be 50, by the way, right? If I were to look at that, right. Okay, cool. All right, so now, if we think about it, the tangent of 40 degrees equals opposite over the adjacent. Okay, I got a big task here because I'm actually teaching you guys tricks. It's kind of a big deal. Correct, right? Because all trig ever is Just so you know, all this ever is just a ratio of sides. That's all it ever is. People think trig is so hard, blah blah blah. Well, it can be hard actually. I gotta be honest, it can be hard. But right now we do it pretty easy. Just a ratio of sides. So if that's 40 degrees, the tangent is opposite over the adjacent, right? So my opposite is clearly 45. Do I know the adjacent? We do not. We call it x. So it's gonna be 45 over x. Now this one gets a little crazy. You have to use a calculator. You cannot do this in your head. If anyone can do this in their head up to 5 digits, I will give you an A for the rest of the year. Go. Anyone can do it? Tangent 40 in your head? No, it's a little hard to do in your head. No, I can't do it either. It's maybe a math savant. I don't know. Tangent 40 in your head. Yeah, it's not going to happen.
I guess.
It's 0.839. Use your calculator. I'll show you actually where we're doing the calculator so it's recorded. Here's how you do in the calculator. Yeah, and X. Yeah. So if I did TI 84. Here we go. Let me clear the screen for a moment. I'll bring it back, don't worry. So by the way, you have to go to mode, and you do have to switch down to degrees. I'll teach you guys radians later in the year. But you have to switch down to degrees. Actually, I think we do radians in algebra too, but we'll go degree mode. And if you hit tangents right here in 40, it'll give you that number, 0.839. And 3 decimal places is good enough. So you can do the calculator that way. So let me oh, switch your mode. You're probably in radians, that's why. Hit mode and go to the 4th line, or it might be the 3rd line for you. And you should see an option to switch from radian to degrees.
So do the 0.839 over like 1 is 45 over that.
Correct. Yes. So you can multiply by x, 0.839x equals 45. What does x equal? 45 over 0.839. I do need to be a little careful how I write this because people can easily mess up the fractions. So we'll do this a few more times so you guys get the hang of it. If I work that out, I should get 45 divided by that number. Crap, 45 divided by, come on, man. I should get 53.63 degrees. Sorry, not degrees, just a side length. Sorry, my apologies. X should equal 53.63 feet. Which makes sense. If I do 45 over 53, it's about 0.8 something. That makes sense. So yeah. So that's how you can tell how far the person is from the tower. Faith, go ahead.
What is a tangent?
Tangent is just it's a way to yeah, it's pretty abstract actually. That's why I was like, okay, I'm teaching you guys trig. It's a way of taking an angle, like say 40 degrees, and ask yourself, how far do I rise and how far do I run? Exactly. It's a ratio. It's a ratio of the opposite over adjacent for whatever angle you're given. So if I made this angle, bigger, right? You think about like if this guy walks
So
closer.
it's basically the slope of a 40.
Yes, it's like slope. Yes, tangent's like slope. Because what if this guy walks closer, right? What happens to this line now? It gets steeper. So I'm trying to find the slope of that line, right? That's what I'm doing. So tangent, great question. I'm glad you asked that. What tangent is, it helps me find the slope of this line. So if this angle gets larger, this gets steeper. So now the rise stays the same. The tower doesn't get bigger. It's not going to magically extend. But does this side get shorter?
Yeah.
It does. So the ratio gets bigger when you do a 45 over a smaller side. If this gets smaller, this fraction gets larger, right? Like what if this guy's like super close to it? Then the angle's like crazy steep, right?
Yeah. Okay.
So that's what it is. Yes, I'm glad you asked that question because I can't.
See the slope of the line for a certain.
Correct. Let me actually write that down because that's very important. The tangent is like the slope of the line or hypotenuse. Actually, of the slanted line. We'll say that. That's better. Leaning Tower of Pisa. Isn't that side slanted? Right? So that's like your hypotenuse. So that's what tangent's like. It's like the slope of the slanted line or the hypotenuse. Actually, that is what it is. It actually is the slope. Yeah, that is what it is. It is a slope. 45 or 53, whatever. That is a slope. Yep. Let's do just a couple more here to kind of wrap it up. So at least you know. Let me set these up for you guys at least, and then we'll wrap it up. So here's the deal. So tangent 38 degrees equals x over 8. Tangent 73 degrees equals 9 over x. Tangent 45 degrees equals x over 14. Now I won't give it an 8 the rest of the semester. But if you don't know what to actually do here, it's actually really easy number. It's a whole number. That's 45, that's 9, how much is this? How much is left over? 45, these both 45, let's do about both sides. Bam, so that's 14, yeah, that's 14. Yeah, so we'll work those tricks. Homework is going to be CPM stuff. I didn't have a chance to copy the homework. I'll have to do that later. I'll just put it in Schoology. I'll put a PDF. I'll give you the problem numbers, and we're all set for today. And start working on that packet. The radical. Start working on that. We'll talk about it tomorrow. Yeah. I don't. I do know it's going to be something less than 8. It's going to be 6.25. And for B, I have to move things around. So. Welcome.